right. So once you start the virtual machine, you should see something like this on your desktop. So what I also do is I'll upload all the commands that I'll be discussing today on Google Drive as a Google Doc. So you can open the doc, and in case you miss a command or you want to just follow up on that, or you are going a bit faster than I am, you can see all the commands that we'll discuss today. Okay, so that file is going to be uploaded now on Google Drive. Okay, so you should see a file, a Google Doc called bash commands in the course folder. The course folder details are available on Moodle announcements. So in case you don't have that, go to Moodle announcements, you'll get this folder link. So click it, you should have a folder called codes, and then you should see these bash commands. Okay, so they have all the commands we'll be discussing today. In fact, I'll be opening this page on a separate window and then discussing these commands. Okay, well, I'll do an Alt Control T and open the terminal and then zoom in a bit so that you can see it. So those at the back, can you read the terminal text? I guess they can. Right, so let's start. Okay, we discussed about PWD. Now initially I'll move a bit slow and then I'll start going much faster than that. Okay, so let's do a PWD, and if I do a PWD, that shows me the working directory. So it will print the working directory on the screen. So that's /home/HPSC. Okay, this is a command. There is also an environment variable called PWD in capitals. So to read the value of the environment variable, I have to do an echo. Echo is a command that will print something on the screen, and then followed by dollar time, and then followed by the variable name. So dollar basically extracts the value from the variable name, and echo will print it. So if I do that, it also prints the same thing. Okay, so $PWD in capitals is basically is an environment variable that contains, PWD in capital is an environment variable that contains the details of present working directory. So I can set another environment variable using this. So let's say I want to have, I want to go to the desktop, and then I can set this complete. That could be a very long path. I don't want to copy paste these things. So I can say lec2 equals and then $PWD. So that now I can see the value of lec2. This is this desktop. Even though I change the present working directory, let's go back to if I do a CD enter, it takes me to my home. Home is /home/HPSC. So if you have a different user on the same machine, they'll be in their home. So now if I do an echo $lec2, it still has that same information because I had stored this /home/HPSC/desktop into that lec2 environment variable. So that is frozen now. Okay, $PWD will keep changing, but if I have fixed lec2 as this directory, that is fixed now. Okay, by the way, I can use the up and down keys to go back to historical commands. Any questions? Okay, we also discussed about setting the prompt. So rather than having this prompt which says HPSC at HPSC ME522 and followed by the directory details, I can set an environment variable called PS1, and this can be set to simply $, and then I want a space for some convenience, and then this changes the prompt. So this environment variable, if you modify it, then it changes the prompt. And clear command will clean the screen, and this will ensure that you start from the top. The next command I'll talk about is ls, which is to list. Now if you are in any folder, you want to see what is there in the folder. If you are using GUI, graphical user interface, you can see it as some directories or files, but for terminal you have to do an ls. So if I do an ls, it prints all the file or the folder or directories or file names that you have there. Ls has some other flags or options available in it. So in fact, there is a command called manual that is discussed in the notes a bit later. So that is denoted by man, man is from manual, followed by whichever command you want, ls let's say, and it opens the ls manual where you have all the options available in ls, and you can go down with the down arrow key or use page down to go one page at a time to see all the details of the option that you have. And if you want to search for an option, you can use the slash key, and then you can type the option that you want or whatever you want to search. So let's say I want to search for -L. I remember -L was an option, but I'm not sure what it is. So I can do a slash -L and enter. So then it takes me to wherever it finds this -L. So I can use the N key to keep moving to the next search which it has found, and I'll stop where it tells me what -L means. Okay, so here it says -L is to use a long listing format. So it will give me a long listing format of the directories and files that we have. Okay, so if I want to come out of it, I can use a Q, it will quit the manual. Okay, so Q is for quitting, N is to move to the next search item, and slash followed by the command and enter is for searching. So slash is for search in manual, N is for next, and Q is for quitting. Okay, right. So I know it's -L. So if I do an ls -L this time, it shows. By the way, after a few minutes I'll give a break so you can try things for a couple of minutes yourself. Okay, so it's up to you whether you want to do that now or you can do it later. So this ls -L, it also tells me the permissions of this file or a folder, the size, the user, the group, the size. This is the size, and then you have the creation date for this file. Okay, so it has lots of information in it, whatever you need. There is also a flag called -A. Now you see that it also brings in some other new files, directories called .ipython, .jupyter. Some files also starting with a dot are visible now, which were not visible earlier. Okay, so files or folders preceded with a dot is for hidden files. So -A will list everything, all, including hidden files. So if you want to see them, you can use an -A. In fact, you can combine options. So you can use an ls with a -L -A, or you can do a -LA. That also means the same thing. So it will combine these. It will list everything and all files. Okay, there is also an ls -H for human readable. So if I do this, then it shows me size in kilobytes, or if it's a large file in megabytes or gigabytes with an M or a G, because if you have lots of bytes, it's difficult to figure out where is how many digits are there. So -H is for human readable format. Now there are many options available. Please feel free to browse the manual for ls. Okay. Some other options are available in by the way, can you open the Google Drive file now? Okay, good. So in the doc that I have uploaded, there are some more commands like -R, -T, -F. So please play around with those or look for them in the manual when we have a break for you to practice. But for now, I'll want to discuss a few commands so that you have enough information to play around with. There's a command called which, WHICH, which basically stands for where is that command that you're typing. If you type, let's say, ls. Now ls is an executable which is stored somewhere in the computer. When you type ls and press enter, it runs that executable. So this executable that runs is stored in /user/bin/ls. So that's the complete path of that file in the computer. Okay. If I write which Python, for example, there's nothing. So if there's nothing, that means Python is not even available, and that is what happens. If I type Python, nothing happens. But if I type which Python 3, then it tells me something. So this is which command is typically used for figuring out whether that option is available or not. You don't want to take the risk of running it, so you simply use which followed by that command. It will tell you whether that command is available. If yes, it will give you the path of the location where that command is running from. Sometimes you are confused that I installed Python 2.1 but it seems to be running Python 2.2. So what is the default Python that it runs? So you can use which Python and then it will tell you the path of that Python that it runs. Okay. Next is change directory cd that we have been using quite often. So if I do an ls with the -l, let's say I want to go to desktop, so I can do cd followed by desktop. I don't need to type desktop completely, I can use des or de followed by a tab character auto completes it. So since there is only one folder or a file that starts with de, it auto completes and then you can press enter, and now I can see it is in desktop. So cd is for change directory. If I want to go up or back, I can use cd dot dot, not back, actually up. So now I am in /home/HPSC. I can even go up. So now I am in /home. I can even go up. Now I am in /, but I cannot go up anymore because I am at the root now. There is nothing above that. If I want to go to my home again, I can do cd enter, that will now take me to my home. So cd, if you are confused and you want to go back to home, you can simply cite cd, that will take you to home, then you can start from there again. Cd with a minus takes you to the last. So let's say you are at a very intricate folder structure now, you by mistake do cd and you come to home. Now you have to type everything and go back. You can do a cd minus, it takes you to the path that you were there earlier. One last step. So sometimes it's quite useful. So you can either use absolute paths or relative paths in Linux. So what that means is, let's say we do a cd and now we are in home. Now I want to go to desktop. Now desktop is available in my home right now. So I can do a cd desktop. That's a relative path, related to where I am. But I can also, let's say I am in my home, I can also type /home/HPSC/desktop, and that will also take me to desktop. So that's an absolute path. So you can either work absolutely or relatively, that's up to you. Okay. If you are writing scripts, you are giving a path to someone, you will tend to give an absolute path. But if you are yourself navigating through the structure, you can use a relative path. Is that clear? Any questions? Okay. The next one is make directory, mkdir. So if I want to make a directory, so let's make a directory called test. It's already there. So let's make a directory called test1. Okay. So now if I do an ls, I can see a test1 directory here. Sorry, here. Right. So I can go into this test1, sorry, cd test1. So I can see the path now. I tend to use pwd a lot just to see where I am, because I have removed that prompt now. So I have to use pwd to show you as well where we are. Okay, now if I want to create a folder called, let's say, test2, but that should be inside test1. So you want a couple of folder structures. So rather than creating one at a time, you can in fact create. So I am inside test1 now. So I will create test2 followed by test3, which is inside test2. But this says we cannot create this because test2 does not exist. So what I can do is I can use a -p. So now what we see is that we have a test2, and if I go inside this, I have a test3. So if you want a folder inside a folder and all those folders are not there, you can use a -p option to create multiple folders, one inside the other. Okay. It's not a very useful command, but sometimes you really want to create things at one go. But I would suggest you, because if you make a mistake here, the names get messed up. It's always good to create one at a time and move on. But in case you want to use it, that option is available. Now there is another command. So I will discuss a couple of few more commands, the basic ones, and then I will let you practice. There is a command called touch. Okay. So sometimes typically what happens is, let's say you have a code that is going to store information which is an output of that code into a file, but that program or a code does not have the authority to create new files. It can only open and write into them. So what you do is you create an empty file. So that is where touch command will help you. So right now there is nothing inside this test3, so I can use a touch followed by file1.txt, and now if I press enter, an ls will show that there is a file called file1.txt in inside this test2 folder wherever I have created. So let's clear it. So we have this file called file1.txt, which is 0 bytes, is nothing in it, it's just an empty file with nothing in it. Okay. Sometimes touch command is also used for changing the modification date of a file. So if you do a touch to a file, you basically open and close it and save it, but do not change anything. Sometimes you want so modification date will be the last date the file was modified. If you want to change it to now, you can do a touch to that file, that will change the modification date to right now. In some cases you want that to appear as the last modified file or so on, so you can do that. So touch basically opens the file. If it's not there, it will create it. If it's there, it will simply open it, save it, not make any change, and then close it. Okay. So you will see how these commands are useful when we use them later. If I want to see the content of a file, I can use a text based editor called vim. So that opens this editor. Now it has certain commands which are a bit difficult to remember, so I will not demonstrate this. We have notepad with the name of featherpad available in this distribution of Linux called Lubuntu. So Lubuntu is basically LXDE desktop based Ubuntu. So this is very light Ubuntu. So this is typically used for old computers which have 2 or 4 GB of RAM, which you bought 10 years ago. You still want to use it. So you would not use Ubuntu because Ubuntu is heavy now. So you would use something called Ubuntu or some other light version of Linux. So this is Ubuntu based but very light. So it has a featherpad as a software installed for editing documents. So I can use featherpad file1. So this opens this editor, and now I can type hello and just Control S for saving, and I can close it with a cross. And now here if I do a cat followed by file1, it will show the content of the file on the terminal. Okay, so cat is for concatenate. So cat is basically going to print everything on the screen. All right. Sometimes the file is very large. If you do a cat, it will show the last few things, and everything else will be gone because of the long scroll it had to do. So you can also use a command called more followed by the file name. It will show you whatever gets printed on the screen, and then it will stop. So let's see if I have a file available on the desktop which is large enough for me to demonstrate this. So I remember this code that we talked about. So let's see this code Jacobi sub. So this is a large code. Okay, so this should help me demonstrate that. So if I do a cat and this code, so you see that it prints everything, but I cannot see everything because the code was quite long. So what I do is I would write instead of cat I'll use more, and then I'll write the name of the file. So it only prints whatever gets printed and then it stops. So it says 25%. So I can use the down arrow key and it will scroll up and down. So it allows you to scroll on the terminal. Now you may say that no, what is the point? I can use featherpad, but featherpad is only available if you have the graphical interface available. If you are working on let's say a remote computer which does not allow you to export graphics, then you typically use this more command. There's also a less command which is very similar. You can use more or less, but it will basically print everything that is possible to be printed on one screen, then you can browse it with an arrow. Now if the file is extremely large and you try to open it with Featherpad or an editor which tries to open everything, it takes a very long time because it will try to load everything on the RAM. That takes extremely long. So these commands, what they do is they only open a chunk of the file, so they are very quick. So because you yourself cannot view the whole file, so what's the point of putting everything on the RAM? When you need that, it will use it. So these commands actually become quite useful if you're dealing with very large files. Okay, so then you can read them by using the arrow. And when you reach the end, it will come out of the prompt and it will come out of the file and it will bring you back to the same prompt that you started with. So this was the command called more command. Okay, then there's a command called remove, which is to delete. It's a very useful command, but we have to use this with caution. So let's say I'm in, let's go back to our test one structure that we had. So let's go to test 2 and let's say I want to delete this file 1.txt. So for this I'll do remove rm followed by file1.txt. Now whenever you use rm, don't be in a hurry to press enter. Make it a habit to just relax, see everything that's available on the screen. Sometimes we tend to use tab and quickly and you press enter and by the time that you wrote a wrong file, it's gone. It's gone, it doesn't go to recycle bin, it just goes away. Okay, so be very relaxed. If you are not sure, you press a -i and then you press enter. So -i is for interactive, it will ask you want to remove the regular file file1.txt. Yes, so you press y and press enter. This is especially useful if you are deleting a folder. So let's say I want to delete, I am in folder test, I want to delete test, I want to delete test 1. Okay, so I am in desktop now and I see this test 1, so I see rm test 1, press enter. So it says yeah, you cannot delete test 1, it is a directory. So for that we have a -r, so it recursively deletes everything inside it and then deletes everything else. So if I do a test 1 -r, it will delete everything. So it will delete test 1 and then it will delete test 2 which is inside test 1, it will delete test 3 also. So all of them will be deleted. So it's always a good option to use -i with a -r option. So descend into directory test 1, yes. Descend to test 2, yes. Descend to test 3, yes. Remove test 2, yes. Remove test 1, yes. So now you can see it's all deleted. Sometimes in your even bash you can modify the rm option so that when you type rm, it automatically does rm -i. So that is an even safe option than if you don't, but you should explicitly use -i rather than trying to use this. And sometimes if you want to force the computer not to ask you, because if you are doing it remotely, let's say you type a script where you have this command that is running remotely, so you cannot type a yes or a no, it's running in the night automatically. You want to force it yes. So for that you can use rm, let's see what is in test. Well, this is something that I did for practice. So let's say I want to delete test directory and I want to do it recursively and I do not want the computer to ask me. So I use an f. F is a force. If you do an f, it will not ask you anything. So there is a very common scary command that is rm star -rf. Star stands for everything. So if you do that on a computer, it will delete everything on the computer. Okay, I will slash star is for everything. Okay, slash is root, star is everything. So if you do that, it's everything. So some people have made this mistake of using typing rm /star -rf, that will wipe out your whole hard disk in just one command without even asking you anything. Okay, so be careful with this rm command. I will not repeat this command again because you will try it out. But you cannot, if you do it on a virtual machine, you will just you have to close it and you have to download a new version. Okay, but if you do it on an actual computer, then you have to reinstall everything and you will lose everything. There is a command called whoami. So if you are in doubt, then you can check So you are HPSC. Okay, sometimes you have multiple users on a machine and you're not sure which user. Sometimes you log in as a root, so you're not sure whether you are a root right now or you are this user. So you can use whoami to check. There's a command called history that will give you a complete history of the commands you have typed. It's a very useful command because you want to see if you have written something and you want to copy it and type it again. In fact, you can do history, and then there's a redirection sign, and you can have a file which, let's give it a name, bash commands for today.txt. So what it does is, so when I wrote history, it printed everything on the screen, but this greater than sign is for redirecting the output to a file, and that file name is bash commands today. So now if you do an ls, you can see this file is now available because you have created that. And if I do a cat, or let's say a more followed by bash commands today, it will basically whatever you saw on the screen with the history command is now available inside this file. So I can now keep this file with me. I practiced many things today. I will just copy this file and email it to me and keep it for my records. Okay. So this redirection of output can be done with the history command. So let's take a break here. I mean break as in like I will let you practice these things by yourself for the next 10 minutes. Okay. If you are able to finish before that, please continue. Raise your hand. I will come up and help you with the stuff later. So you can take your 10 minutes is yours for to practice things, whatever you want. This is the software carpentry website I was talking about. So if you go here, you can browse the website yourself. It's a very, very useful website for people who are interested in scientific computing. You can go to our lessons, and here there are lessons available on, let's say, Unix shell, version control, that is something we'll discuss in this course, programming with Python, again something we'll discuss in this course, plotting with Python, programming with R, and R for reproducible scientific analysis. Okay. So they have lessons in English, Spanish. They also have some lessons in Make, again something we'll discuss as a part of this course, MATLAB and SQL as well. Okay, so it's a very useful thing. So for Unix, for example, so in Unix, so if you go to the website, so there is a website, there is a repository, and it also has instructors notes. So in case you want to teach the course, it has some extra information for the teachers. So here is the Unix shell. So on the left hand side, it talks about some lessons. So it starts with introducing the shell, navigating files and directories, working with files, then advanced ideas like pipes and filters, something we'll discuss today. Loops, writing loops in bash, shell scripts, writing whole scripts that you can execute at one go, and even to find things. So this is a very useful link. Some of the topics I have taken from this website for today's discussion. You can please, I'll urge you to try it out yourself in your own time. So the next command I want to talk about is, next part is to have a bit more advanced discussion on the commands we have talked about. So for that I'll need some files so that we can play around with them. So for that we'll be cloning the software carpentry Unix shell folder structure. So that's available on Git. So let's so on the desktop I will create a folder, or rather I'll go to home, and I have a folder called GitHub where I store all the repositories. I already have downloaded this, so I'll delete it to demonstrate it again to you. Okay. So for that what we'll do is we'll do use a git clone command. We will discuss more about Git in the next lecture. So, for now you can think of it as a command to download something from the internet from GitHub website, and then I have to give the path which is github.com/ the handle where this repository is available. So, that is SW Carpentry. By the way, you can go to their I have already got the link in the doc, so you can copy it, or you can just Google it, copy it, and then type it, and they'll shell-novice.git. Right. So, it's downloaded that. So, you can see that there is a folder called shell novice which is available. So, we will be using the content available in this structure. So, let us go to by the way, I can do an ls shell novice. So, that tells me what is inside it. In fact, if I do a ls minus r, sorry, capital R. So, that will recursively tell me what is inside all the folders in this structure. So, very useful because rather than going inside everything which can be quite daunting, I can easily see what is inside. So, shell novice has something called this structure which is got all the files. Then it has something called episodes. Inside episodes it has these files. Then it has data and fig. I am not interested in that. So, let us move on. It has something called file system. So, that inside file system it has this. Not interested. I am more interested in something around shell lesson data. So, let us go to that. Well, shell lesson data has two folders, exercise data in North Pacific Gyre, and then in exercise data it has these folders and so on. So, I am now clear what I want. Okay. So, ls with a minus r can be quite useful if you want to see the whole tree structure that is available. By the way, ls with a minus capital S with an L will sort your results, okay, by size. So, let us go to this folder that I want to go into, shell lesson data and exercise data. So, inside this I have these folders. So, if I do an ls minus L, this is what I get, but if I do an ls minus L with a capital S, it will sort them by size. So, let us go to alkanes folder, and here I have files which are of different sizes. You can see one is 1152 bytes, one is 622 bytes. So, if I do an ls minus L with a capital S, it will sort them from largest to smallest. I can actually do a minus r also, I think. That will reverse the sorting, so it will go from smaller to largest. Sometimes you want that, you want to choose the smallest file out of 1000 files. Okay, so you can sort them and choose the first one. Okay. There is a command called mv, which is for move, and a cp for copy. So, let us say I want to copy this file called cubane.pdb into another file called cubane1.pdb, so that I can change the first one. It is like creating a backup. So, or just say cubane backup. Okay. So, now if I do an ls minus L, you can see that this cubane underscore backup has been created. So, this cp command is for copy. First you write the file you want to copy and then the name of the file that you want to copy into. Okay. I can remove this cubane underscore backup now because I do not want this. I can even make move it. So, let us say I create this backup again and I want to move this backup because I might delete all the files in this folder. So, I want to move cubane underscore backup, but where do I want to move it? I want to move it one folder up. So, I will say dot dot slash, because dot dot, remember, is going up. So, dot dot slash basically means you move it to one folder above. Now, if I do this, you can see this backup file is not here, but if I do a cd dot dot and if I do an ls minus L, this cubane backup is available here. So, I moved cubane backup one folder up. Okay. So, let us go to this alkanes again, and let us demonstrate wildcards. So, let us say I have lots of files and I want to look for files which have the extension PDB. So if I do an ls star.pdb, that will list all the files which have an extension .pdb. Now in this case all of them had .pdb, which is fine. So let's create another file by using the touch command, or file called test.txt. So now I have another file called test.txt. So if I do now ls star.pdb, that will only list the files which have PDB extension, and if I do a star.txt, that will show me the text files. In fact, the star, what it does is it expands into all. So what happens first is star expands to everything. So star.pdb will expand to all the file names, and then it will run the ls command. So one way to check this is I can write echo followed by ls star pdb. So echo, what it will not run the ls command, it will tell me what command is going to run. So when I write ls followed by star.pdb and preceded by an echo, what it does is it actually tells me that you are running this command. ls star.pdb is equivalent to running this big command. So star.pdb is expanding to a list of these files, and then it passes them to ls, and ls runs this command. Okay, is that clear? So star is for anything. There is also a wildcard called question mark. So let's say I have files which have thane, like ethane. So if I do an ls star thane.pdb, what do you think that should give? It gives ethane and methane. It's a thane, right? THANE, because cubane, octane, pentane, propane and test, they do not have this. It's only ethane and methane. So these were the only files which had THANE. So that star got replaced by anything which matched this. But if I do instead of star I use a question mark, it only gives me ethane. So question mark can only be replaced by one character. So anything followed by thane, but that anything has to be one character long. Okay, so that is ethane only. So if I write star followed by ethane, it gives both ethane and methane, because star can be nothing also. Okay, so ethane is also matching star ethane, because star without anything, star being nothing, is also matching this. But if I write question mark ethane, then only methane is chosen, because question mark has to be replaced by some character. So it got replaced by m and we got methane. So these star and question mark, they are called wildcards. They are quite useful when you want to run commands on multiple files which have some pattern in them. Right. The next command I want to talk about is, by the way, these commands are there in test, and I will also share this video with you, so you can practice them later. There is the next command is called wc, which is for word count. Okay. So if I let's say I have these files, let's open, let's do a cat cubane, cubane. Oops. So cubane file has this text in it, right? So if I do a wc cubane.pdb, it is for word count. So it counts the number of lines, then number of words, then number of characters. Okay, so wc command will count these things. They are quite useful if you want to count the number of lines or number of words or number of characters in a file. If I only want the number of lines, I can use wc with a -l and then cubane.pdb. So cubane.pdb has 20 lines in it, so it only gives me the number of lines. Now what happens if I do a wc -l followed by a star instead of a cubane? Any guesses? Well, star gets replaced with all the file names. In fact, I can check, I can do an echo and see what actually it expands to before even running it, because see, running that can take maybe hours to run, whatever that command is, I don't know. So before that I can use an echo and then see what actually is running. So it will run this command wc followed by -l and then all these file names. So it will do this wc -l on all these files. I could have rather use this command, then wc followed by this. And sometimes we do that because let's say I have 20 files and I only want to run wc on 10 files. So I'll generate this complete thing and delete those 10 files and then copy this command and use it in my script or wherever I want to use it, because you might be adding new files but you don't want to run wc on those new files. So this gives you some sort of a way to generate that command. Okay, so this runs this on all the files. So Cubane has 20 lines, ethane has 12 and so on. I can even sort it. So how do you think we can sort these using the size or the number of lines? Well, one way is that I can redirect the output into a file called wcount.txt. So if I do a cat wcount.txt, that is the output of this wc minus l star. So it has the line counts of all the files. But now I want to sort it. So there is a sort command which I can use with the minus n. I will tell you what minus n is, and then wcount.txt. So it basically just sorts the content of that text file in increasing order. I want to see what this minus n is, so I can check the manual of sort command and I can do a slash minus n, press enter. So it tells me that minus n is for numeric sort. Okay, so numeric sort means that 20 is larger than let's say 3, but if you don't do it, then it only checks first. So 22 is smaller than 3, so it will only check for the first alpha. So alphanumeric versus numeric. Okay, so it will take these numbers as actual numbers. 0 is a number, 9 is a number, 12 is a number. But if you do without minus n, we can actually try it. So it sorts 0 comes before 1 and then 9 is the largest. So it only sorts based on the first character. Okay, so if you do a minus n, then it sorts taking all these numbers as actual full numbers. Is that clear? And what I can do now is I can sort this and the output can be redirected to a file called sorted.txt. So this sorted.txt has line numbers for number of lines for each for all the files sorted in the right order. Now let's say I only want to find the two smallest files in this in this list of files. Okay, so what I do is sorted dot, so I can use a command called head and I can say I only want that first 2 lines of this sorted.txt. So it gives me the first 2 lines, and since I know that sorted has the file names sorted in the right order, so I get the 2 smallest files I have. So this is a nice way to extract the first 2 files. There is also a tail command. So if I want the last 2, then I get, in fact it gives me total also, because total also is there, it adds everything and gives a total, but that is useless. So what I can do is I can do a tail and redirect it to another file called last, let's say 2.txt. So last 2.txt has these 2 and I can take the first one out of this, so which is head minus n1 of last 2, so that gives me octane, that is the largest file. To extract the second last, I exported both last 2 and then took the first one of them. Okay, it's a lot of work, right? So what I did was I did a word count into a file, sorted into a file, last 2 into a file, the first one printed or whatever I want to do. Is there a way, could there be a way if I could combine all this into one command? Well, that is where an advanced idea called piping in Linux comes. Who has heard of piping or used piping before in this class? Nobody? Okay. Well, then this is new idea. It's a very, very amazing idea in Linux that all of you will nowadays and from now onwards use, now that you know it. So let's use piping. So piping is like, you connect a pipe between 2 commands. So first command is I want to do a word count minus L on all the files. This is what I get, right? This is the output. You pipe it, the output, to a sort command with a minus n. So it sorted the final output is this, and I only had to run one command. Now I want to take the last two lines out of this. So whatever you have, you pipe the output and you take the tail with only two numbers, last two lines. You get last two lines. Now I want the first one. So I pipe and do a head minus n 1. So this is how, this is just one command, complete command that you can use to extract the file which has the largest number of lines out of these all files. It's an amazing idea, right? If I had to ask you to do it manually beforehand, you would have taken a lot of time. You would have manually done it by opening all the files, counting them. So this is I mean something you can, Linux is quite useful if you know how to do these things. Any questions? So this command is there under the piping section. I think it is line number 123 in the doc. So feel free to try it out, but I will want to just discuss a few more commands, so that these are advanced commands. So even if you don't understand them right now, you can try them out later. This is a command called cut. Okay, so for that I will take you to a folder called animals. So let's go up a bit. There is a folder called animal counts. So let's go into that. There is just one file called animal.csv. So let's have a look at the content of that. I will want you to focus right now because this is a slightly advanced idea. So you have this content here, and let's say you want to extract now some information from this text file. So let's say I want to extract only the name of the files. It's immaterial how we generate this file. This file is there. So it has some date of generation of the file name, and let's say the number of lines it has. I use some command to generate it, but that's okay. So let's for that we have a command called cut. So cut, how do you want to cut it? You want to cut it using comma. It's like reading it's a CSV file, right? Comma separated. So I'll the delimited character is comma, and then when you cut it, you get three values in a column, right? You get the date of creation, you get the file name, and you get the size. I want the file name, I want the second column. So you want second field, minus f is for field, you want the field number 2, and which file do you want to run this command on? On animals.csv. So this extracts this information. It's very quick. I mean, you don't even need to open this CSV in Excel, you just extract the information. Okay, now what we see is that I actually want to sort this list in alphabetical order. Well, that's easy. I have this piping command. I can pipe the output and use the sort command, and I don't need to use minus n because it's not a numeric sort, it's alphabetical sort. So now it sorts starting with B and going all the way to R. But I have repeated information, deer, deer, rabbit, rabbit, because they had different sizes and so on. So I can use a command called unique, which will only give me unique values. These repeated values will be removed. So this quickly helped me figure out the unique file names which are available in this CSV. Okay. So again, you can do many interesting things with this cut command. Feel free to check the manual for this cut command to check for this. Now the next advanced idea is looping. So we are moving up very quickly. Okay. I strongly urge you to practice these things if you have never used them before. So let's go to a folder called creatures. Here you have a couple of files, 3 of them, unicorn, minotaur and basilisk. So what I'll do now is let's for reference just see what is there in this let's say basilisk. It has some DNA sequence, okay, of this animal. So this is some DNA sequence. Again, I don't care about the content, I just want to practice my loops. So for that, let's say I want to extract the second line. So let's open it using the more command. So the name starts every file starts with a common name, then classification, then updated, and then some DNA sequence. I want the classification from each file. It's a very valid requirement, right? You have, let's say, 100 files. You want the classification and you want to print them. You just want to give it to your supervisor for them to have a look at what classifications you have for different animals, right? So for that, what I do is, how do I have to open them, extract the second line, and then print it somewhere, right? Or extract to a file. But what I can do is I can actually use a loop. So I can use a loop where I will say for file name, again this is there in the doc file, for file name in star.dat, because all the files have a extension dat, okay, and then I say, so now it takes me to a different, so now the loop has started. I have to type commands in the loop. So now I will say do, but what do you want to do? First I want to print the file name, so I will say echo $file name. So remember, file name is going to contain some value, so $that will print the value and echo will print it on the screen. So echo $file name is going to print the file that you are working on, okay, fair enough. Then now I want to extract the second line. So for that, what I will do is I will run the head command. I will take the first two lines of file name, and then I want to take the second of those, so I will take the tail and I will take the first one from the bottom, and then I will say done. So now what it does is it prints, it echoes the file name. So for file name in star.dat, what it does is star.dat expands to 3 file names. It's like a loop. For those who have, I mean, I'm sure everybody has used a for loop earlier in some programming language. So if you say for something in a list of things, so it will go to, it will run the loop multiple times for each value in that list. So first it takes basilisk.dat, it echoes the file name, so it prints that. Then it says head -n2 $file name, so that will take the first 2 lines, and then pipe the output and tail the last one, so that is the second line of the overall file. It prints that and runs that for all the files, okay. If I use the up arrow, it gives me the whole loop command in one go. So it basically, I can also write this as for file name in star.dat, rather than using enter, I can use a this semicolon and then do echo this semicolon command semicolon done. So that also gives the same thing. So this is looping in bash. Now if you want to go back, I can use a control back arrow, or I can use a control A that takes me to the beginning of the line. So if you have a very long line, you want to move around from first to last, you can use control A or control E. Again, I have put these commands in the text file, in the doc file, so to move quickly from one to the other. Now it's not important to remember these, okay, it's important to know that you have a command. So when you need it next time, you will automatically figure out what it is, and when you start using it, you will get used to it. Any questions? So by the way, in history, let's say I have a history here and I have to read, I want to search for a command where I used let's say some command, cut command, okay. So I will have to read the whole history, rather than I can use a control R. Control R is for recursive search in history. Then I can write cut. So it automatically brings the line where it matches that cut command, the latest line. And I can now use control R multiple times to go from, go back in the history to the place where I had the cut command. So if you want to repeat a command, you can do that using this control R. Okay. So control R is for searching in the history. Okay. Now there is one idea before I want move to grep, shell scripts. Now these there is even advanced idea called scripting, where rather than you using it, you can create a script, give it to a user, and they can now use it. So let's do that. So let's say you want to use, you want to run the, let's go to the alkanes folder again. Okay, so I have all these alkanes here as PDB files, and let's say you want to run a command which is going to be head -n and then you want to extract the first n lines from a file. So for that the command is head minus n, and let's say 3 lines out of the file, and which file do you want? Let's say you want cubane. So that gives the first 3 lines for the cubane file. Now you don't want, the idea could be advanced. I mean, you can redirect the output, and then you can take the tail minus n1, so that gives you the third. Let's say you want to extract the third line from each file. Okay, but let's keep it simple for now. Let's say you want to extract the third line from each file. You will write this command, right? Now you want to give it to a user. So for that, what I will do is I'll actually create a script. It's called a shell script. So let's create that. So let's do feather pad. Let's call it script, and for shell scripts the extension is .sh, shell sh, and here I will give the command head minus n3 followed by cubane.pdb. Let me store this, Control S, save, and then close it. So I can do a cat and check the script. The script contains this text called head minus n3 cubane.pdb. So I can now run it, bash script.sh. So it runs the script. You don't need to run the command again. You can store it, and then you can keep it in a script, or you can give this script to someone else, and they can just run this script with bash command, bash followed by the script name. By the way, be careful, because scripts can have remove commands, and they can just copy your data. So don't run this. It's like writing an executable. So don't take somebody's script and run it without thinking what is there. It's basically anything that you can do, the script can do. So it can literally email stuff from your computer to someone else. They're executable, so they are dangerous. Some bash commands, some shells will not even allow you to run without giving you a warning. Anyways, so this is what you want, right? I can even make it more advanced. This is quite mundane. This is quite basic, this script. So what I can do is I can modify this script. I can say that the file name will be specified by the user. Let that be the case. And even the number of lines will be specified by the user when they're calling the script. So let's I'll put a $2 here, and I'll put a $1 here, and then close it. Now I'll do a bash followed by a script, and when I do it, it says that option requires an argument, because I've not specified. So $1 was the, I think it was the file name. So $1 was the file name, and $2 was the number of lines. So that basically means that the first option you give after this is going to be the file name. So I can just write cubane, and the number of lines I want is 3. Oops. No, not cat, sorry, bash. Yeah. So when you run this script using the bash command, one basically stands for the first thing that you have supplied after the script name, that's cubane. Now I can change it. I can change this 3 to 2. It gives me the first 2 lines. I can change it to 5. I can even change the file name cubane to, let's say, methane. Gives me something else. Okay. It's very useful, this scripting, and in fact you can do many advanced things in the script, and then give it to someone, and you can tell them how to. This is just 5-minute discussion on scripting, but scripting is amazing. It can be very advanced. So these ideas will help you to understand if you are doing things and that is boring you, doing the thing again and again and again. There is something called scripting that you can use to automate that whole task. Any questions?
So in that bash command, in the above line you have written that $2 for the number of line and $1 for the number of the name of the file. So in this bash command you have written the file name first and then the number of line. But sir, in that script, you have specified that number of line.
Let me check. Okay, I understand your question. So $2.
Is for the number of line, no, sir?
So what?
So it is coming after the file name.
So see, the head command is head minus n, followed by the number of lines, followed by the file name, right? So number of lines is the second option that I have given.
Okay, sir. So we can do this, sir. I'm asking that, like first.
You can call it 1, you can call it 2, then you can specify the number